Hello, ladies and gentlemen. This is Mrs. Eisenman. We have a lesson today on systems of equations, and we are going to address these three main points. First of all, is a point a solution to a line? Is a point a solution to a system of equations? And we're going to talk about how to solve a system of equations graphically. Now, yesterday in class, you should have picked up 3 sheets that are in your notebook that we're going to use as the outline for these notes. So what I want you to do is make sure that you have those out, and you are just going to follow along just like you would in class and take the notes. Make sure you're writing everything down. If at any point during the lesson you need to pause the video and rewind it to listen again in case you didn't catch something, please feel free to do that. That's one of the most powerful parts of having a math lesson in this way, is that you can pause, rewind, and replay. All right, so let's get started. Okay, the first sheet that you should have in front of you looks something like this. At the top it says, is a point a solution? Okay, so what is this really asking? It's really asking, is the point on the line? So if a point is a solution to a line, it means it's on the line. When you plug in the x and y coordinates, are the right and left hand sides of the equation equal? So we have an example here to try this out. Determine if the point -3, 7 is a solution to the equation 2x plus y equals 7. Okay, so algebraically we're going to do these 2 steps. We're going to plug in the x and y values from the point into the equation. So they gave us this point -3, 7. We're going to plug that into the equation. X in for x, y in for y. And then we're going to ask us this question, does the left-hand side equal the right-hand side? If the answer is yes, then it's a solution. If the answer is no, it's not a solution. Okay, so we're going to take the equation and we're going to rewrite it to start. So you're going to go ahead and write down 2x plus y equals 7. And now, like I said, we have this point, -3, 7. And we know that all coordinate points are x, comma, y. So that means I'm going to put -3 in for x and 7 in for y. Okay, so I'm putting -3 in for x and 7 in for y. So I'm going to rewrite this equation with those numbers. 2 times -3 plus 7 is equal to 7. And now we're just going to evaluate the left-hand side. So if I were to type the left-hand side into my calculator, okay, or do it in my head, 2 times -3 is -6, plus 7 is 1. Does 1 equal 7? And hopefully you're all going to tell me, no, it does not equal 7. And therefore I would say that this is not a solution. Okay, it's that easy. All right, let's move on to the next ones. Okay, the next question is a multiple choice question that you could have on your exam, and it just says which point is on the line 4y minus 2x equals 0. So what they're doing is giving us 4 possible solutions to this equation. So in order to answer this, we're going to go through and we're going to do point by point, plug it in until we get one that works. Okay, so we're going to start with choice 1. And I'm going to take the point -2, -1, and remember again that x, comma, y. So I'm going to take my equation, 4y minus 2x equals 0, and I'm going to plug in the y as -1, so 4 times -1 minus 2 times the x is -2, and see, does it equal 0? So when I answer this, I get -4 plus 4. So -2 times -2 is a positive 4, and 4 times -1 is a -4. So actually right away I get 0 equals 0. And so the very first point is on the line. Okay? All right. Now, just like the first example we didn't work, if I tested choice 2, 3, or 4, we'd see that those points were not on the line because they wouldn't work. The left-hand side would not equal 0. All right, number 3. So number 3 is a question where it gives you a point, but notice in place of x, you have a variable k. So in place of the x, we have a k, and the y is -3. And it's saying that point lies on the line whose equation is x minus 2y equals -2. So I have x minus 2y equals -2. And they want to know the value of k. And so basically, I am going to do just what I've been doing all along. I'm going to put the k in for x and the negative 3 in for y. So I have k minus 2 times negative 3 is equal to negative 2. But instead of just checking does the left equal to the right, this time I need to solve for k. So now we need to go ahead and solve this little equation for k. So I want to go ahead and take my negative 2 times negative 3, which hopefully we agree is a positive 6. So k plus 6 equals negative 2. And then I'm going to solve for k by subtracting 6 from both sides. So k is equal to negative 8. And so I can see that choice 1 is the right answer for that question. Okay, so now we're going to start talking about systems of linear equations. And I just want you to understand that systems of linear equation means when you have more than one line. Okay, we use this word system to basically indicate that we have 2 or 3 lines. Generally, we're just going to have 2. Okay, so if we have 2 linear equations that are graphed on the same graph, or if we are doing operations with them, that is called a system of linear equations. And so right here, it talks about what is then a solution to a system of equations. Well, it's any point is a solution to a system if it makes all equations true. In other words, if you can put that point into both lines and it works for both of them, it's true for both of them, then we would say it is a solution to the entire system. The solution set of a system is the collection of all points, all xy pairs, that are solutions to the system. Okay, so number 1 wants us to determine if this point, 2, 5, is a solution to each of these 2 different systems. So we have 2 different systems. So like I said, a system is just a set of linear equations. So in part A, this is our system of equations. We have 2 linear equations. And we have to determine if 2, 5 is a solution to that entire system, which, like I said, means that we are going to take the point 2, 5, which of course is x comma y, and plug that into both. So I'm going to start with the first equation, the y equals 4x minus 3, and I'm going to plug in 2 for x and 5 for y. So I'd say 5 equals 4 times 2 minus 3. Does 5 equal 4 times 2 is 8, minus 3 is 5? And yes, it sure does. Okay, so now I'm going to take the second equation, 2x plus y. Does that equal 9? 2 times, again, put 2 in for x, 5 in for y. 2 times 2 is 4, plus 5 is 9. 9 equals 9. And so because it works in both, I can then say yes, it is a solution. Okay, now let's check letter B. Okay, so now I'm still working with the same point. I'm still working with the point 2, 5, which is x comma y. Okay, my system for part B are these 2 linear equations, y minus x equals 3 and y equals 1/2 x plus 6. So once again, I'm taking this point, 2, 5, and plugging it into both of these. So y minus x equals 3. And so I'm going to go ahead and take my 5 and put it in for y and my 2 in for x and see, does the left equal the right? 3 equals 3. So that one does work. All right, let's try the second equation. Y equals 1/2 x plus 6. So 5, does that equal half of 2 plus 6? Well, 5, half of 2 is 1 plus 6 is 7. And definitely 5 does not equal 7. Now, even though the point worked in one of the equations, but not the other, we would say that it is not a solution. So not a solution. Okay, it has to work in both. So it is not a solution to that system of equations. Okay, we can also look on a graph to determine a solution to a system of equations. We know that linear functions can be graphed on a coordinate axis, and we talked all last class about y equals mx plus b and how to graph lines on a coordinate grid. Okay, so what if I graph 2 lines on a coordinate axis and I want to determine the solution? Well, using a graph to determine a solution to the system of equation means finding the point or points on the graph that are true for all equations graphed. This can be found where the graphs And hopefully you're looking at this picture here and you're kind of thinking through what would happen if a point was true for both lines. Well, it'd be where the graphs intersected. Okay, so we're looking for the point of intersection on the graph, and that will be our solution to the system of equations. So if you look at this example we have right here, a system of equations is graphed on the set of axes below. Where is the solution? Well, like I said, we are looking, okay, this line is made up of an infinite number of points. This line is made up of an infinite number of points. The only point that they share would be this point right here, which of course would be always x comma y, so over 1, 2, 3, 4, and up 1, 2. So we would go x comma y, and so 4, 2 is our solution to that system. Okay, now the big questions that we're going to face tonight are looking at if we want to solve a system of linear equations graphically. So how are we going to use our coordinate axes and use what we know about graphing lines to solve a system graphically? Well, we just talked about the solution is found where they intersect. So it looks like what I need to do is get my lines on my graph paper and find their point of intersection. And that's exactly what these steps are going to take us through. Okay, these steps tell us first to get each line into y equals mx plus b form so that I can graph it. Then I'm going to graph each line. Then I'm going to label the line with their equation. And lastly, I'm going to name the point of intersection as the solution. Okay, so point of intersection, point of intersection is the solution to my system of equation. All right, so we're going to start with this first example. So let's start by taking 4x minus 2y equals 10. In last class, we spent a lot of time practicing getting them into y equals form. So if I want to graph, it has to be in y equals form. So we're going to move the 4x over. So I'd have negative 2y equals 10 minus 4x. And then I'm going to divide by negative 2 all the way through. So I'd end up with y is equal to negative 5 plus 2x, because I have a negative 4 divided by a negative 2 there. All right, so for that first equation, I can say that I have a y-intercept of negative 5, and I have a slope of 2, or 2 over 1. And I can say that because I know my slope is attached to the x, okay, and I know my y-intercept is the constant by itself. So now I'm going to go ahead and graph that line. So I'm going to go ahead and go down 5 on the y-axis as my y-intercept. 1, 2, 3, 4, 5. And then I have a slope of 2, which means I go up 2 and to the right 2. So up 2 over 1. I'm sorry, up 2 over 1. Up 2 to the right 1. Up 2 to the right 1. And I want to make these pretty long when I'm doing a system because we're just not exactly sure exactly where it's going to be. Okay, we want to make sure that we are connecting these points with a straight line. So we want to go ahead and do that. Use a ruler or a straight edge or the edge of your paper that's what it takes, but you want to make sure it's a nice straight line. Okay, so I've connected my line and it should look like that, okay? One thing I want to do right away with my line is label it, because oftentimes if I don't do it right now, I'll forget. So I'm going to label this as y equals negative 5 plus 2x, right on there. All right, next I want to take the next equation, which is y equals negative 2x minus 1. Now, this one very nicely has already been solved in y equals form. So we're going to go ahead and just name our y-intercept and our slope. So our y-intercept here, remember, is the constant, the number that's standing by itself, which in this case is going to be negative 1. And our slope here is the number attached to the x in front of the x. And so our slope here is negative 2 over 1. So now when we graph this, we're going to graph it as down 2 to the right 1. Okay, so we start at our y-intercept of negative 1. And now I'm going to go down 2 to the right 1. Down 2 to the right 1. You can see as I look at my dots here that I'm definitely going down as I move from left to right, which indicates a negative slope. Once again, I want to make sure I use a nice straight edge or ruler to connect those points. Okay, so again, I've graphed in now my second line, and again, I need to label it with its equation. So y equals negative 2x minus 1. The last thing I need to do, which is super important, is to name my answer. So everything that we've done up to this point is really the work. But if I want to solve, I want to know what is the answer. Well, the answer is that point that is true for both equations. It's that point of intersection. So that would be this point right here, which I would definitely name as positive 1 and then down 1, 2, 3, so negative 3. Remember, it's always x comma y, so I'm going to name my point of intersection, my solution, as 1, negative 3. That is my answer for the first example. Okay, number 3 in your notebooks, what we would like you to do, please, is go ahead and try this one on your own. Use number 2 as an example. Okay, go through those steps. First, get both equations into y equals mx plus b form. Okay, get them both into y equals mx plus b form. Name what the slope and the y-intercept is for both equations. Then graph the lines, label the lines, and name the point of intersection. Okay, so go through and do those steps with this number 3 example. And in class tomorrow, we're going to look to see if you've done it, and we're also going to go over it with all together as a group. And then we'll practice some more of this next time in class. Okay, thank you so much. I hope you have a fabulous evening, and we'll see you next time. Bye-bye.